Okay. Welcome back to uh, virtual laboratory. Am I audible properly?
Yes, sir.
Yes, sir.
What about the screen?
Visible, sir.
Visible, sir.
So, okay. Thank you. Thank you very much. So, welcome back to one and all. So, this is our MT virtual lab. Aim of this lab is to understand how the experiments are carried out by virtually, because we are not able to conduct practically at this situation. At least we need to understand how to conduct these experiments. So we are I am trying to uh, convincing you to how to conduct the experiments by virtually. Yesterday we have been discussed about the introduction about this MT lab, material testing lab, and also we have been discussed the importance of this material testing laboratory. Many of them are absent. About 40% students are present yesterday. No problem. So as I told, as we all discussed yesterday, attendance is very important, because that's affect to your internal marks. So we need at least more than 85% of attendance, right? And we have been discussed about the importance of the material testing lab. Whatever the things we have been discussed in the previous semester in material science subject regarding the engineering materials. Basically, we have been discussed about the mechanical properties of engineering materials, because we are all engineering, mechanical engineering students. So our focus is only on mechanical behavior of the engineering materials. In that sense, we have been discussing a number of mechanical properties, how they does, how they attributes their results. All these things we have been discussed in the previous semester only. That is only the theoretical part. It is through theoretically how we can able to understand that we have that we already done. But the thing is, unless we are not having that practical experience, this will be the incomplete. That will be or that was the incomplete experience, or that was the incomplete portion, unless we are not conducting the experiment. Because whatever that theory we have been gone through the classrooms or some any other books, that is based on the experience, based on the skill. So how we are going to conduct the experiment, that is very important practically. At least we are trying to understand how to conduct this experiment. All these things already we have been discussed. I will not take much time to again to repeat these things. I'm directly coming for the experiment number one, Rockwell Hardness. That also in orally we discussed in the previous class. However, it is once again we will start the experiment number one, that is Rockwell Hardness test. And also I will tell you the scheme of this laboratory, you know very well, so I will not take much time to discuss about that. So as we all discussed yesterday, list of the experiments here, around about 8 to 10 experiments here we are listing through this virtual lab. All these experiments are suitable for our framed syllabus. At least 80%, almost all the major experiments, as we are have been discussed in the last class, part A and part B. Many of the majority of the experiments are comes under the part B, major experiments, which carries 50 marks. So as I told yesterday, around about 80% we can able to cover the syllabus through this virtual lab. So some are experiments are missing in this list, which are comes under minor experiments. So once the lockdown is lifted, once the college reopens, we can together we are conducting in our laboratory. However, they are the minor experiments. Here, out of 8 to 9, all are under the major experiments. Let's start the experiments. Yesterday, we have been just orally or briefly, we are discussing the Rockwell Harness test. Right? Am I audible properly? I'm asking everybody.
Yes, sir.
Huh?
Yes, sir.
Okay.
Audible.
Okay, so you have suppose your mind is thinking or arising any questions, so you can ask me anytime, no problem. See, before going to the Rockwell harness test, I would like to ask you again. Instead, also I'm asking. No one are able to answer my question. So, what exactly harness? The harness is one of the mechanical property we know. The how can you define the harness property? Come on, quickly. We have only 1 hour. So, please, anyone, how can you define the harness property of the engineering material? Hmm? No? Okay, yesterday I have defined this harness, the ability of the material to resist the indentation or penetration, or other words, the ability of the material to resist this scratching, cutting, or some flaws, or some penetrations over the surface. That particular, if you can say that material has a very hard, sir. That material has a very high hardness, sir. If that material does a very hard, definitely that material will not allow to get easily scratches, or that will not allow to penetrate easily. That material will not allow to make something scratches or flaws, indentation, penetration over the surface. Hence, we can call it as a hard material. Best example for the hard material is a stainless steel, some other 18 bar 8 steel, high speed steels. Some other harder materials are there. For example, in some ceramics materials are having excellent hardness properties. So all these kinds of the materials, just I'm giving you the examples for the hardness materials. Be careful. You can note it in your book. This is very very important at the time of the Viva. Just you can give an example for the hard materials. Most of the ceramics materials are best example for the hardness. Ceramics materials, you can call it aluminum oxide, boron, tungsten carbide, tungsten carbide, boron carbide, aluminum oxide, cuprous oxide. High carbon steel is the best example for the harness. High carbon steel. In that we have a category of stainless steel, high speed steel, 18 bar 8 steel. And another best example is cast iron. Cast iron also one of the best example for the harness. I hope you this is enough for examples. Now theory, we don't want theory. Theory already you have been discussed in your theoretical classes. Once again, I will not take this theory. And directly I am coming to the minor load, major load. While we are conducting the experiment and while we are discussing the procedure, I will explain about the minor load and major loads. Though we have been discussed in the last class. Once again, I will take, because yesterday we are discussing. Today we are planning to conduct one experiment, so that while we are discussing the procedure, I will explain about everything. Now, what will be the minor load, what was the major load, and everything we will discuss. So specifications of this is about we can call it is our Rockwell harness machine. It is, as we can see, the image is a Rockwell harness machine, right? Here we have a chart. So see. Here the thing is there, this is the very important thing. Now I am focusing on this scales. So here we have a dial indicator, so keep it in your mind. While we are discussing the procedure, this will be the very very important. Meanwhile, we should understand now, this will be in future, this is very very important. Here we have a dial indicator. In this dial indicator there are three scales: A scale, B scale, and C scale. So what they are indicates, there are three different scales are there in the dial indicator, and what they are indicates, see here they are indicates. If suppose that A scale is indicates type of the indenter, also that A is indicated type of the indenter. What type of the indenter means dimension of the indenter based upon the materials. So here I will come one by one. So A scale, if it is a scale, so A is as indicated the dimension of the or type of the indenter that will be indicated. and that indicates load also, minor load also, as well major load also for particular kind of the materials. That A is specifies these type of the materials. Which are those? Much harder, such as carburized steel and cemented carbides. Yes, as I told you that some ceramics materials. If you want to determine the hardness value of the carbide materials, in that sense you can focus only the scale A, because this diode has three different scales. So if you are using these kinds of the carbide or harder materials, at that in that cases you need to take the type of the indenter with respect to the materials, because the A scale A is indicate the cone type of the indenter, or sometimes diamond type of the indenter. Degree is 120. Apex angle, we can call it sometimes apex angle. Apex angle will be the 120 degree should be, and initial load means minor load should be 10 kg and major load should be 50 kg. You have to follow all these parameters if your material is harder materials. Then also you can note down the readings only the B scale. And suppose if it is A or C is present, least bother about the other scales. Only your focus is on A scale because of the material. Hope you understand. Keep it in your mind. This will be the very important while conducting the experiment. And coming to the B scale, see, so B scale, what it indicates. So ball indent, always B is indicating the type of the indenter is ball, spherical shape. Here the cone or diamond type. Here the ball will be, sorry, indenter will be in the form of balls. Ball, the diameter will be 1.8 mm approximately. Sometimes we will take the 2 mm diameter balls we are using for conducting the experiment. So again it is initial load is 10 kg, but major load is 100 kg. What kind of the materials we can able to take here? If it is the B's indicates these kinds of the material, kind of the materials is, or else if it is through the scale, or else through the material you can select all these things. Suppose if you collect or if you get aluminum or soft steel, copper, aluminum, brass, gray cast iron, all these are medium hard materials, means ductile materials. Most commonly all these are the ductile materials. These are all brittle materials and these are all the ductile materials. Soft steel, copper, aluminum, brass is a copper material, and gray cast iron. These are the medium strength, not good strength, and medium hard material. So hence we can take the scale is B scale. We need to take the ball indenter, and load will be, initial load will be the 10 kg force, and major load will be the 100 kg force. Okay, now coming to the C scale. So cone will be the 120 degrees Celsius, means the indenter will be the cone shape. Kg will be 10 again. Major load will be 150 kg. Here what kind of the materials we need to take? Again here much harder materials. So again it is a harder materials. Spring steel. Spring steel is also comes under the most commonly these are the alloy steels. High hard or high carbon, sorry, high alloyed steel these are. So spring steel is a high alloyed steel. It is definitely this has a high strength and high hardness material. And also one more material is titanium and vanadium, sorry, so tungsten. W means tungsten, titanium, tungsten, vanadium, and the other alloyed materials. Suppose your steel or your any other alloying elements are there, you need to determine their hardness. Then you can go through the C scale. Very important. This is the basic information. So you should know the, while we are conducting this, while we are performing the experiment. When performing the experiments, you have to have these basic sense. And also in the sitting in front of the examiners at the time of the vivas. So such kinds of the questions he may arise. So you have a we have to, or you have a capability to answer. And also this will be very important. So while we are conducting the experiment, I hope you understand about these things, right? Now I'm coming to just I will show you about the how the indenter. This is one kind of the indenter. It is a cone type of indenter or a diamond shape of the indenter. We can call it as a diamond shape of the indenter. So also minor load is how much it will be indented. So only the surface will be up to this portion if it is minor load. Up to this portion is just enter into the workpiece. So not this portion, is the upper line and below line. There are two hash line. There are as we can able to see the two hash layers are there. So the first layer, this is the hash layer. We can this portion will be dig into the material whenever we can apply it to the minor load. The second hash portion when we are applying the major load. The total portion, this is the this just for understanding we can see how the forces. This is the first force and this is the second force. To this force we can able to compress or we can press the indenter into the workpiece till the indentation or print over that particular sample. Once we got the particular perfect impression or print over the workpiece, then we can stop the work and but we can note down the reading. So I will explain everything. So coming. Okay. This is the arrangements of your Rockwell harness machine, and here we can able to see the different types of pieces or different dismantling, different machines or different machine elements which combine together to form the machine or dismantling parts of the your Rockwell harness machine. So one more different machine it is annually. So here we have a different types of the anvils. So this is one type of the anvil. We can easily we can rotate this screws or screw handles, so we can raise the anvil. This is one type, and this is another type. We can rotate this hand wheels to raise the anvil. This is one more type of the machines here. There are different hand wheels or different anvils we can able to see here because of different applications and different situations. We can able to select these kinds of the machines, right? I hope you understand about this. This is about all these things are comes under the theory part. Yes, any doubts? Shall we start the procedure? Huh? Shall we move? Hello, are you there? Yes. Okay, this is only the theory part. Okay, now so we will focus on the procedures. The theory part is over. So the things, whatever the things we need to understand, that I explain you. So that's better for understanding the experiment. Now I'm coming to the procedure. See here there is a procedure. So how to conduct the harness test. Aim. So I will start from the aim. Aim is to find the Rockwell harness number of mild steel, cast iron, brass, aluminum, and spring steels. So any one of the material you need to, and all the materials we need to determine the hardness value. Or in other words, you can also say that the aim will be the to determine the hardness number of the given sample. But it is to determine the hardness number of the given sample. Given sample may sometimes it is mild steel, cast iron, brass, aluminum, or spring steel. And even out of all these, in practice lab we can take all these different kinds of the materials. We have to have that practice for different samples. In examination, out of these materials, anyone you can get. So you need to perform on that particular selected materials, right? This is the aim. And now the step one, I will show you the step one what it is. Okay, right. Before going to the step one, now I will show you the machine. Yes, this is the apparatus. This is, we can call it as a Rockwell harness testing machine. It is. So see, this is the so here we have an anvil. So this is the anvil. This is the hand lever, or this is the screw, and this is the platform or anvil platform. This is the hand wheel. Now once we start rotating clockwise direction, this screw will be the riser. So then it will touch to the indenter. Here this is the indenter holder. This portion is indenter holder. At here we have a tip. So at the tip we need to fix the indenter. this is indenter holder, and this will be indenter. So the indenters are already we have been discussed. Different types of the indenters are available. Based on the types of the material, we need to select the indenter. Indenters are available in different shapes and different dimensions also. If it is depends upon the material, may sometimes it is a diamond shape, sometimes it is a ball shape. If it is a diamond shape, you can look into their angles, right? If it is in ball shapes, you can look into their dimensions or diameters. 1.58 already we have been discussed, or 2, sometimes 2.5, the diameters are available. Based on the materials, you can able to select. You can fix it into the indenter holder, and this is the dial gauge. Here we have, there are 3 different scales, right? So this is the load unit. Here we need to set the loads. Here the different loads are available. So it starts from the 50 kg to up to 300 kg force. So we can able to set here. So there will be a screw is there. So you can set the loads. After setting, this is the hand lever. You can load it and unload. With help of the hand lever, you can load this way. You can load, and so this way you can unload. The forward is unload. The backward side is a load, right? So once again, I will show you the simulation of this lab also. Now, yes. Step 1. Here we can start this step 1, right? So what is step 1? So we focus on this. Is very important. So how to conduct the experiment? So it starts from the selection of the material, that we can call it as a step 1. Select the specimen for your choice: spring, steel, cast iron, mild steel, brass, aluminum. As per your choice, as per the examiner choice. Hope you understand. This is the cast iron. This is steel. This is spring steel, mild steel, spring steel, brass, aluminum. So different types of the samples are available. As per your choice, you can able to choose, or else the examiner choice, you can able to select the materials. This is the first step. Keep it in your mind. Yes, coming to the second step, right? What will be the second step? The hand lever is turned until the specimen is contact with the indenter, and the pointer of the small dial gauge reaches the red dot, so that the minor load of 10 kg is applied. Okay, I will explain what it is. In step 2, once you select the raw materials or given sample, may it is aluminum or it is a mild steel, spring steel, or cast iron, right? Once selection is over, you need to select the parameters before coming towards to the machine. You need to select the parameters, as I told you that before. Chart B, C, A, B, C. Whether the, if suppose if you selecting the aluminum material, what kind of the scale we need to focus? Tell me. If it is aluminum samples, now we are coming in front of the machine. What kind of the scale we need to focus? If it is aluminum, tell me, come on, quickly. Otherwise, this will be waste of time.
Wasted.
What?
B, sir.
B, 100%, 100%, 100%. What is your name?
Shuk Mercy.
Raghavendra.
Huh?
Shuk Mercy.
Sikwasi and?
Yes, sir.
Raghavendra.
Okay. Very good. So we need to select the B scale, right? So I hope you understand. So based on the kinds of the material, we have to select the B scale. Type of the load means, okay, type of the load, type of the indenter, type of the minor load and major load, indenter, everything, sir, everything we already selected based on the types of the material. Only we need to perform the experiment. Yes, right. Now, yes, it is over. Now we are selecting. So here something is writing red dot. Okay, we reaches that dial gauge is reaches to the red dot. Here this is a, I will magnifying the image of dial indicator. Here we have the dial indicator. Now I am magnifying that dial indicator here. Here you can able to see scale C, scale B, right? Sometimes we can call it a scale A, we can call it is. Sometimes one more scale is available, but for our applications, most of the applications, most of the machines, one more, depending upon the machine, that machine sometimes has all the 3 scales, sometimes that machine has only 2 scales, B and C. Here we have a B and C scale. So the red dot means here we have one more small dial is there. That big dial, inside that big dial we have one more small dial, as you can see here. This is what a small dial. Here we have a red dot. Okay, now we are selecting the materials and every parameters we are selecting. Later you can keep the samples upon the anvil, right? Once you are keeping your sample upon the anvil, then you can select the indenter. That also already we have been selected. Now just we need to fix into the dial indenter, indenter holder. Now we are selecting the indenter or penetrator. Now our penetrator is also we have been set into the penetrator holder. Let's start performing. Once you are keeping this sample upon the anvil, you can start it. Everything will be set now. Now you can start rotating the anvil. Okay, you can start rotating anvil in clockwise direction. This screw will be rise up and the platform also rise up. Just touches to the workpiece. That workpiece, surface of the workpiece is touched to the indenter. We have to make ensure that that workpiece will be touched to the ball indenter or diamond indenter. Surface of the indenter and surface of the workpiece should be in close contact, because we need to transfer the load from, we are selecting the, we need to transfer the major load, so that we make ensure that the surface of the workpiece and surface of the indenter should be close in contact. So how much this should be close in contact, that is also calculated here. We need to, once you touches this workpiece to the indenter, this red dot is start moving. When these two are come in contact, workpiece and ball indenter, these are come in contact, definitely this ball indenter, sorry, this red indent in the dial, this will start moving. Then you can rotate the anvil. This red dot is this pointer. Here we have a small pointer. The small pointer, somewhere it is, earlier it is somewhere it is here or here. Whenever we are touching this pointer, this not red point, this small pointer is momenting or fluctuating. Just you can turn and turn and turn. This small pointer is just reaches to the red dot. Here you can see the small pointer is there. That small pointer is now is touching to the red dot, but initially it was here or here or here, somewhere it is. Whenever we come in contact with these two, this will be momented. We make ensure the small pointer is just touches to the red dot. If you make ensure this, or this should be done, does mean that minor load is applied. Yes sir, we make ensure that small pointer is touching to the red dot, sir. We did it, sir, or we done, the work is done. That does mean that minor load of 10 kg is applied by manually, because we need to make ensure the small pointer is touches the red dot. That's what we are applying to some minor, we are applying some human load. For that we are rotating the anvils by forcefully. Manually we are rotating the anvil right now. That manual load we can call it is a minor load. Approximately it is 10 kg force to 15 kg force. Yes, now this pointer is correctly touches to the red dot. Now you can stop it, right? Okay, now next level. This is step 2. In coming to the step 3, yes, this is where making sure that small pointer touches to the red, and also however that surface of the both indenter surface and workpiece surface will be close in contact. Now you can select the loads. Yes, coming to the this side. Here we need to apply. Now already we have been applied the minor load. Now we need to apply the major loads. Minor load, definitely, I hope you understand. Definitely, sure it is. The examiner, definitely the examiner will be asking what you mean by minor load, what you mean by major load. Already, I hope you understand what is a minor load, where you can get the minor load, how you can apply the minor load. You need to understand. And coming to the second step is, now we need to apply the major load, right? So how we can apply the major load, sir? Yes, as per the types of the materials, already you have been selected the loads, whether it is a 100 kg, 150 kg or 50 kg. Based upon the type of the material, already we have been select these parameters. Now we need to set it, that's it. So here there will be the arrangement. Yes, here we can see. So here there will be the arrangements of the loads. The loads are 150, 200, 250, 300 up to, there will be the load setters with help of the button. So you can set the loads. That I will show you in a simulation. So now we need to set the as per the required loads, 150, 200 or 250. That is depending upon the type of the material. So once you set these loads, you can load it. Now this is in unload condition. Now you can pull back. Once you can pull back this lever, now it is in loading condition. This is, we can say it is step 3. It's clear? It's clear or not?
Yes, sir.
Yes?
Yes, sir.
Yes. Now we'll move on to the step 4. Again, step 3 already I have explained. Now once you already explained what happens once we unload it. Yes, once we pull back, yes, once we pull back this lever once, what happens? Now once you are pull back the lever, so here there will be the movement of the dial indicator, so big indicator in the dial, that will start moving, that will rotating, or that will be start moving over the dial. It will be rotating like this, right? Rotating like this, as that we can able to see here. Then you can unload it. Here we are, so here we are red circle, what it indicates, the click on the hand lever to unload it. One thing you should remember, while loading you don't take the readings. While loading also, this pointer will be rotating, and that will stay after some times, that will stay at particular point, right? You don't take that values because that is in load condition. So we can wait for few seconds, or few seconds means we can wait for 15 seconds and 10 seconds in a load condition. You don't take the values, any values. After 15 seconds or 20 seconds, 30 seconds, again we can unload it. Just we can full forward. Now initially earlier we are pull back, this is the load condition. Now we can make ensure that lever in unload condition. When you are we are putting this in unload condition, again this pointer is start rotating. Wait for the 30 seconds and 20 seconds. This is, we can call it as a steady time. Some people are in a hurry, still this pointer is moving like this, or fluctuating here and there, here and there. The people are taking some values, they are in hurry. Don't do that. You will give the sufficient time for that pointer should stop at particular point. That will be the steady of that pointer, that we can call it a steady time. You have to wait for 20 to 30 seconds. Thereafter that pointer will be steady at particular load or particular number. Now it is a 94, because here 90, 91, 92, 93, 94. So this is 95. In between the 94 and 5, here the 94 we can take this. The Rockwell hardness number, after unloading, again this pointer will be rotated. Then it will stop at particular number. Then only you can note on that number. That number is called as Rockwell hardness number. In short form, RHB. Why B? In short form, we can write it RHB is equal to 94. What B stands?
Number.
Yes,
Yes.
scale. Because scale means that value is tell us, or suppose if you are writing R HB, so that people can understand, oh, they are conducting the Rockwell harness, they are conducting the harness test, that is particularly R stands for the Rockwell, H stands for the harness, and B stands for the particular scale, because we have three different scales, which scales they are prepared. Then they can understand the B scale. Once they are understanding it is a B scale, then that leads to, or that will give the information regarding the materials also. Everything will become in picture. If it is a B, then what kind of the material they are taken, that also, and what kind of the material we are conducting, what kind of the material it is, everything will be understanding through that. That's what the most commonly you might have observed that the many of the books are writing HRC 94, BHC 100, like this they are writing. The HRC means HRC or HRB. Here HRB is there because RHB. R means Rockwell, H means harness, B means B scale. B scale is particularly which we are using the type of the material. You can understand the type of the material also through this. Hope you understand. Now we will, once it is unload, we can give the study time. Particularly in the examination, what you mean by study time? Definitely the question will be what you mean by study time. I hope you understand what is the study time. Okay, so this is the post step. Then cast iron is a B, so 94, right? Material cast iron total kg 100, already we have been discussed. This is what the chart. Material cast iron we are selecting, so total kg is 100. The scale is B we are using. Rockwell, see here RHN. Sometimes they are writing RHB here instead of N, they are writing the B, which means which scale we are using. 32 we will get. This is the first trial we are able to get the 32. The number of trials which we can take. So here, second time, so here they are showing the 94 in the sense. So how we are conducting the number of times, that we will get the different values. Don't issue, no issue with that. Now we are getting for the harness number for the cast iron is 32. Second trial we are getting the harness number 59. Then we need to take the 2 or 3 trials. So that is depending upon your convenient time. You can take 2 trials, 3 trials, because we want the average value of the hardness number of the given sample. Here they are taking 2 readings. One is 32 first trial, second trial is 59. The average of these two we will get the 44.5. This is the average Rockwell hardness number. Always we need to determine the average value of the hardness number. I hope you understand this. Only there are simple 4 steps which we can able to get the hardness value of the given sample. Any doubts regarding this? Hello?
No, sir.
No? Any doubts? I hope you understand the procedure, right? And this is a very simple experiment. There is no calculation, nothing else. After that, this is you need to write the procedure. See, note on the procedure, and you have to write the procedure. So after procedure, and here we need to draw this tabular column, and finally you need to write the results. This is what results. I hope you understand this procedure, right? So now I will, yes, now I will take you into the simulation. Now I am trying to show you the simulation so that you can understand better how this experiment is carried out. Okay, simulation. The first step of the simulation here we can able to see. So here the instructor or you can or any student is now ready to conduct this experiment. This is our harness testing machine. So here that person is carried out the experiment, right? Now, yes. Now this is the simulation. Now here we have types of the materials: cast iron, mild steel, spring steel, brass, aluminum. Suppose if you click on the cast iron, see If you click on the cast iron, what kind of the indenter we need to select, that will be shown here. See, once I click on to the cast iron material, so here we will get the type of the indenter. Type of the indenter is ball. Or else if you click the mild steel material, again it will show the ball indenter. You can go back to the chart. In cast iron also we need to choose the ball indenter. In mild steel also we need to choose the ball indenter. If it is a spring steel, so here the indenter will be changed. This is the cone type of indenter or diamond shaped indenter. Cast iron also ball indenter, mild steel also ball indenter. If it is a spring steel, then the indenter will be changed. Again brass, soft ball indenter. Again aluminum, same ball indenter. Hope you understand this is.
Yes, sir.
Yes. So the how you are changing the materials, that indenter will be changed. This is the I can able to show you through the simulation lab. Next we will go next. Yes. Here there will be the pointer is there. This is the red dot. Now, so here there will be the indication. Next procedure indication it is. Now I will show you. So once I click on this button, what will happen? Let's see. Right. So the anvil is ready now. What will be the next? So here there are different types of loads are there. Once I click on to this here, the load will be selected here. Simulation. Just this indication. Now I am clicking. Yes. Yes. Now he is setting the 100 kg force. Then we need to load it. Yes. Now I'm clicking this hand lever. Let's see what happens. See here we can able to see the pointer is momented. At this stage you don't take the readings. Right, that somewhere this will show some values. You don't take these values because this is in still it is in load condition. So here also it is. This is the seconds. How much? This is the steady time. How much we can able to wait, sir? Some people are in hurry. They are immediately unload it. No, you don't unload immediately. Wait for this time. Yes, it is 30 seconds. Now we can click the button. Yes. Now again it is moving and now it will show the Rockwell hardness number. This is the exact Rockwell hardness number, is a 71 of the particular material. Now the pointer will showing us this is what Rockwell hardness number. Yes, the cast iron we are selecting, load we are selecting 100 kg, scale we are using the B scale, Rockwell hardness number we are we got 71. Let's take a next trial. This is second trial. Again everything will be ready. Now we are touching this workpiece into the ball and enter. Now the red dot is, now this red dot will be moved once we are clicking this button. See, you can able to see the red dot. So here that small pointer is not touching this red dot. Once we click on this red dot, here you can able to see here. You can simultaneously you can see this small pointer and big pointer. Once I click this button, you can able to see this big point as well as the small pointer. What happens in this dial indicator? You can focus. You keep your eye on this dial. See, once I click it here, see, this will be moved now, right? Is it right? Now the pointer is, the small pointer is now coming to the red dot. Now it means now we are applying the minor load around about 10 kg force. Yes, the minor load is done. Once we are applying the minor load, then we need to apply the major loads. Hope you understand this is about the applying the minor loads. Now we will move on to applying for major load. Yes. Yes, now this indication will shows for apply the major load. Yes, now we are applying the major load. How much it is? It is, I think, 100. I think shows 100 kg because of the cast iron. Now we need to load it. We are selecting the load, major load. Now we need to load it. Then you click on the lever. Yes, you can able to see this pointer and this point. This is for the study time. This is for the pointer is moving, but because this is the applied load. So whenever we are applying the load, this will be the moment. We don't take these values unless and until we are not unloading. We don't record the values from the dial indicator. So we have to wait for the 30 seconds. When this pointer will be reaches to the 30 seconds, now we can stop the process. Yes, now we can click this. Yes, now it's moving. Initially it was showing like here. Now it will show here. This will be the 87. This is the second try. Now what will be the next? Yes, now directly we can get the average value of the Rockwell hardness number. That first trial we have got 71, and second trial we have got 87. The average of 71 and 87. So here there is the average hardness number of the given sample is around about 79. Exactly 79 is the hardness value of the cast iron. Hope you understand.
Sir.
So how to set the minor load, how to set the major load, how to rise the anvil, and how to get the how to take the values, right? What will be the minor load, what will be the major load, and what will be the study time, what means red indication, what it means, what is the importance of red indications, everything you can able to choose, and what will be the B scale and what will be the C scale, how you can select the B scale and C scale, how will you select the indentor load, right? Hope you understand these things.
Yes, sir.
Yes. So this is the assignment. You can take the snapshot or you can write it. These are the assignments. So you can practice this assignment. Why it is necessary to do the hardness test. So now I'm giving you these questions are very important for your external Viva questions. Note these questions. Definitely this will be the internal and external. So what is the necessary to do the hardness test? One question. Second question is describe the procedure for the Rockwell test and explain the reason for the free load. So what are the materials generally we use for indenter? So different indenters, different materials which you can use. This that you can able to so elaborate. And what are the precautions to be taken before conducting the experiment? Very small precautions we need to take. Sometimes there are people are taking the gloves. No need to take the gloves, but though we need to send precautions, safety measures, shoes, some informs. So this is not a big issue. And what is the principle involved in the Rockwell harness test? Okay, this is here where self evaluation is there. Yes, start with self evaluation. If you want to evaluation yourselves, how I am understanding this process and procedures, that is we can measure ourselves. That is what self evaluation. You can answer me. We'll ask you some questions. So diamond indenter can be used for materials having the hardness for any values below 20 hardness, above 20 hardness, and none of the above. Just you can guess as anyone.
None of the above, sir.
Yes, exactly. So I'll guess is this. No, check the answers. Wrong. It is above 20
About 20.
HRC. So keep it in your mind. Above 20 HRC, we can choose the diamond indenters. Next, we will go to the next. What is the diameter of the Rockwell ball indenter? Okay, let's guess the answers
1 by
so that we
16,
can
sir.
so that we can get the correct answer. Huh? Which when I choose? Huh?
1 by 7.
1 by 3.
1 by 3. 1 by 7. No, no. So okay, let's see. Now I will take the 1 by 16 inch. Okay, we will check whether it is right or wrong. Yes, it is right answer. And one thing you keep it in mind, 1 by 6 inch and 1 by 8 inch is most commonly which we are using, because you can convert that. Definitely we will get the 1.58 mm or approximately 2 mm we can get 1 by 6 and 1 by 18 inch. Can convert it 1 by 6 and 1 by 18 inch. Definitely we will get the more than one or near equal to 2. 2 mm we will get. Okay, next we will take that one. So load applied for the Rockwell C test is more than the Rockwell B test. True or false? Load applied for the Rockwell C test is more than the Rockwell B test.
False.
False.
False,
Okay, we will take false. Okay, we will take the false. Wrong. It is
True,
true.
sir.
It is true. Okay. Why the minor load is initially applied in a Rockwell test? This is very, very important. I told you now. Why the minor load is initially applied in a Rockwell hardness test? Specimen cannot bear the major load. Second, to distribute the load acting on the specimen, to firmly seat the penetrator into the position or position for major load. None of the above.
B to distribute the load acting on the specimen.
Okay. Okay. Shall I take this one? Distribute the load acting on the specimen. Don't worry, we will get the correct
Third one,
answer. Third one. Shall I take third one?
yes, sir.
This one.
Huh? Anyway, we will get the answers.
Third one.
It's okay. Third one is right answer. It is right. Okay, we will go for the next. What is the unit of Rockwell hardness number? Anybody?
Dimensional number. Dimensional number.
Dimensionless?
Dimensional number.
100% right.
That's number.
100% right. Answer is go for the next. No, see your score. So we all together answer 3. Okay, three answers for 5 questions. Okay. Right. Okay, now the time is around about nearly 3. Okay, tomorrow we'll discuss the second experiments, that is Brinell harness testing. Okay, Brinell, just I will tell you the Brinell test. Brinell test is also for the determination of the harness, because there are 3 harness machines and harness methods we have for determining the hardness number of the engineering materials. All the 3 machines are very, very important because they have their own perspective, so that we can able to take all the 3 experiments to determine the different engineering materials. Okay, tomorrow we will discuss the vinyl hardness test and how this works. Everything will be discussed in the tomorrow class. Now I will wind up this class. Wait for a minute. We will take the attendance, and I think. I hope you utilize this virtual lab.
Yes, sir.
Yes.
Yes, sir.
Sir.
Yes, thank you very much. Now you can leave your meeting. So,
Thank you, sir.
welcome. Welcome.
Sir, ID change ಮಾಡಿಸ್ಬೇಕಾಗಿತ್ತು ಸರ್.